So today we're covering the sheet metal application in NX. There are so many useful functions that make it faster and easier to generate sheet metal parts and accurate flat patterns from basic to complex. The great thing is you can stay within the NX ecosystem as it's part of the NX workflow. You'll notice in the ribbon bar that a lot of the command names are familiar terminology to what you would be used to, in easy to follow, easy to find in the logical design workflow, which is essentially what you see outlined here. So NX sheet metal is kind of organized in creating sheet metal parts via these steps. Now there's different methodologies, but one simple way would be to create the base shape, bend the base shape, add flanges and corners and cutouts, and deform features. So again, this is the sheet metal creation workflow. There are ways that you can set global parameters initially. So every sheet metal part follows the same thickness rules and other specifications you can make for your application. And then it's super easy to quickly add bends or corners, flanges, and jog features. So let's hop into NX and see how we can do that. So first I'm going to make sure I'm in the sheet metal application that I can access here and quickly create my initial base feature or tab by selecting the tab command. And I could either create a sketch externally or within this tool. So I'm going to click sketch section and create the sketch from within the tab dialog box. So I'm just going to sketch a rectangle really quickly and constrain this to 100 millimeters across. And we'll call this 150 and finish our sketch. Now this command is pulling this thickness from the global parameter that you can set in sheet metal preferences. I'm going to click OK to accept. So that's super easy to do. And now I'm just going to add an initial bend feature by selecting the bend command. You don't need to have a line that reaches completely across the feature for this to work. You just need a simple sketch indicating where you want your bend line to be. So I'm going to sketch that on top of my tab really quick. Select the front face, and I'm just going to add my line here, and I'd like that to be 50 millimeters from the edge. And I'm going to select finish. And now the bend command will automatically recognize that line and give me a solution. Now this is not the solution I want exactly, and so I can change the geometry using the bend properties. I'd like to reverse direction, but I could also change the side that I want bent, or change the outer mold line profile, or where I want the material. So it's super customizable to your application. And I'll click OK to accept. So one other thing I want to highlight about NX sheet metal is it's super easy to add flange features. So some flange features that are easily accessible would be lofted flanges, contour flanges, normal and hem flanges. And these two on the side, the lofted flange and the contour flange, can actually be used to create base features initially, so you don't have to make a tab. You can just go straight into that command and make your part super quickly. And then the hem and normal flange features utilize a base feature and modify the base feature either to eliminate sharp edges or add thickness or whatever you're hoping to achieve with that flange feature. So let's hop back to NX. And we'll add one really quickly. I just want to add a simple normal flange feature. I can select which edge I want it to recognize. In this case, I'd like this edge, and it gives me a solution. So I want to make sure that this is facing the same direction as my previous bend in my prior example. So I'm going to change the direction, make that length 50 millimeters, and add that on all sides. And I'm going to select OK. And I have my initial base shape. Some other awesome features about NX sheet metal are the corner geometry or different deform features such as dimple, louver, bead, solid punch, and gusset. Due to time constraints, we won't go over all these today, but one simple deform feature that I'd like to demonstrate first requires flattening the part. So we're going to create a flat solid by selecting our stationary face and clicking OK. Now, the flat solid is going to be different from our flat part. This is just to be able to visualize what it will look like for manufacturing, and you can toggle that on and off just to check what your part looks like, and it will automatically update as you add features. So I'm going to turn that off and then actually unbend all of these previous bends. Great. And then I'm going to add a louver feature. I need to create a cut line. So I'll select this top face, add my line, finish, and then it will automatically select that line and create that feature. I'd like it to face the other direction, so I'll change that requirement. And I can also change the depth and the width and the shape from formed or lance depending on the geometry I'm looking for. You can also pattern this and create a vent. For example, you could have several in the linear pattern or whatever fits your specific application. So in summary, the whole workflow in NX sheet metal would be to create your base feature, add bends, add corners, flanges, and jog features, add deform features such as louver, and then unbend and flatten the part, either to visualize it for manufacturing or to create a flat part that's basically like a 2D drawing for downstream use. So this is one simple way to create NX sheet metal parts very quickly and efficiently, but there are other methodologies such as create from solid model that could be helpful in a different application. So again, NX can provide faster, more efficient design. And this session covered the sheet metal design workflow from the base feature creation to flat patterns for downstream use. So feel free to reach out to us if you have if you need any additional information or want to learn more about streamlining the modeling process for a specific application. And again, some advanced capabilities we didn't cover today, but our sheet metal from the solid command, adding PMI to a sheet metal part, or using analyze formability to see stress and strain as you're bending your sheet metal component. So that concludes this demonstration. So let me know if you have any questions. Thank you.
Yeah, Ali. So the first question we have is, what is the difference between flat solid and flat pattern?
Thank you, Kelsey. Yeah, so flat pattern and flat solid are super useful tools for different purposes. The flat solid command will create like a flattened 3D representation or flat solid of the sheet metal part, and it's a non-timestamp feature, so you can make changes in the part navigator and the flat solid should automatically update. And it's great for visualizing your sheet metal part as you work through the design process. The idea is to kind of toggle back and forth between the flat solid and your formed sheet metal part just to check and make sure it is manufacturable and there's no like overlapping geometries that would make it difficult to stamp or cut. And the flat pattern, in contrast, will give you just a 2D representation showing the bends and cuts that can be annotated like a drawing.
All right, thank you. And then we have another question here that's a little broad, but you can answer it. And if there's more, we can also be connected via email. But the question is, at Saratech, what kinds of designs do you create using NX?
All sorts of
Yeah.
designs. It is so, the applications are so broad. It could be anything from some to make some little widget fit in a certain space claim, or it could be a way larger project, a huge assembly. There are all sorts of different applications for NX. It just is kind of a endlessly helpful tool. So I would say I don't know what you couldn't model in NX.
Yeah. Yeah. And so if you, Ria, have any specific thing that you were looking to design, please reach out to us and we can maybe help you with anything specific. And then next question, we have another one here is, how do you connect the edges of the bent section?
Let's hop back to NX really quick for that. So I assume you mean like corner geometry. So let me rebend. Well, we'll just hop back here to this example. So this example shows those bend edges connected via the closed corner command. So you can decide how you want to close this geometry. You can have close and relief. You can determine the overlapping properties or corner properties. And you can also, if you want to close this corner, create like a circular cutout. So it's still feasibly manufacturable and can stamp, but you can specify all of that in this close corner command. Or a 3-bend corner command, depending on how many walls you have intersecting.